So let's go over more examples in 2.3. I'll let you look at this one on your own. This guy right here, all on your own. It's a bit more complicated, but spend some time looking over it, but don't fret over completely understanding it. But it's good to try to stretch where you're at right now and look at more stuff. So let's take a look at the sum laws. Here's the sum laws. Write this down. We want to prove it using the definition of limit. So these don't just, hey, it seems to work. You have to have some way of proving it. So what we're going to do is use the definition and similar process to what we did above. So if you have, sum law says if the limit of f of x as x approaches a is m, and the limit of g of x as x approaches a, the same value, equals L, then the limit of the sum as you approach a is just the sum of the limits. Okay, so let's go through this. This relies on the fact that each limit exists. We have to make the assumption of this first part. Anytime you do an if-then statement, you assume the hypothesis. So this if part is what we call the hypothesis, or it's the antecedent, but you assume that's true, and then you make an implication that this has to be true. So let's take a look at that. So first thing you would say is assume that the limit of f of x as x approaches a equals m, and the limit of g of x as x approaches a equals L. So it's that, it's like if you have P implies Q, you have to assume, when you're trying to prove something like that, you have to assume P is true. That's the technique for an implication. We know, so given that, we know we have stuff already. We have stuff we can get out of that. So we know that for every epsilon greater than 0, there exists a delta 1 greater than 0 such that absolute value of x minus a less than delta 1 implies absolute value of f of x minus m is less than epsilon. Right, and epsilon's arbitrary. And there exists a delta 2 greater than 0 such that absolute value of x minus a less than delta 2 implies absolute value of g of x minus L is less than epsilon. So here's the thing. That's because of the assumption. That's the definition of a limit. So by the definition of limit, we get that. So what we have then, what we want is given any epsilon greater than 0, we want to find delta greater than 0 such that absolute value of x minus a less than delta implies absolute value of f of x plus g of x minus quantity m plus L is less than epsilon. So we want to look at what we can do. So what we're going to say then is a couple things. Let's do some research first. So do some research. Okay, so this research, we're going to look at absolute value of f of x plus g of x minus m plus L. And we can simplify that. That's really f of x, or rewrite it, f of x minus m plus g of x minus L. And then we can use the triangle inequality to write absolute value that's less than or equal to f of x minus m plus absolute value of g of x minus L. So that we can say then is less than, and if we write this as epsilon over 2 plus epsilon over 2, that's going to equal epsilon. So what we can do then is come back here and say, let's suppose that it's epsilon over 2, like that, for your choice of delta 1 and delta 2 that's already given. Okay, so that's true. Let me just also finish stating that. That's by the triangle inequality, this piece right here. Just want to make that clear. So that's by triangle inequality. Can't finish it in there. So to finish this proof then, what we're going to do is we're just going to let epsilon be greater than 0. Okay, so that was all research right here. That didn't do it. It's about a 50-50 chance to get that to actually be a box. There, that's my research. Let's continue with the proof then. Okay, so we always say that. Then we're going to choose delta, not delta 1 or delta 2, but just the one we want, delta, to be the minimum of delta 1 or delta 2. So whichever one's smaller, then it has to hold, basically. And then you just restate it. If absolute value of x minus a is less than delta, then now you can just restate basically that stuff. Okay, and I'll write that out again. So then absolute value of f of x plus g of x minus m plus L is equal to absolute value of f of x minus m plus g of x minus L. And then by the triangle inequality, that's less than or equal to absolute value of f of x minus m plus g of x minus L. So that's strictly, so then by the assumption, that is less than epsilon over 2 plus epsilon over 2, which equals epsilon, which is exactly what we wanted to prove. Okay. So again, another technique and a lot of stuff going on here, I know. So try to spend some time studying it. Again, like I said earlier in my other video, I will have you prove a linear case, but not like this. But I do want you, the whole point of some of this is you got to stretch. You got to go beyond where we're at and try to stretch your mind to grasp this stuff. And you will. You just take some time to think about, sleep on it sometimes after you read through it and write it up. Okay, I think that's good. Moving on to one-sided limits in 2.4. We'll do the definition, but we won't work with it directly. And then 2.5 is continuity. And then what else do we got? Since I'm talking here, 2.5. So a lot on 2.5. I think that's it.